So today we're going to learn about solving multi-step equations. In previous lessons we learned how to solve one-step equations with addition, subtraction, multiplication, and division. Today we'll learn about how to solve two-step equations and multi-step equations, so even more than two steps, using a combination of addition, subtraction, and multiplication and division. So one tip I'll leave you guys with is to make sure each side of the equation is simplified before using inverse operations. So that doesn't really take effect in the first two examples, but it will in example 3 and example 4, so we'll talk about it there. So for example 1, it's 2x plus 6 equals 16. So we want to make sure each side of the equation is simplified. So the left side, 2x plus 6, that's simplified because I can't add the 2x and 6 together because they're not like terms. And then the right side of the equation is simplified because there's just that 16. So when you're solving equations, most of the time, especially if it's in a form like this, you want to undo addition and subtraction first. You always want to if you can, it's just the problem is you can't always do it first. So we have 2x plus 6 equals 16. I have 2 being multiplied by x and I have 6 being added to that. So I want to undo what's being added. So in order to undo adding 6, I have to subtract 6 from both sides. So this plus 6 and the minus 6, those are inverse operations, so those cancel each other out. I'm going to bring down the 2x. Make sure you bring down the equal sign and it stays in line where it's at. And then 16 minus 6 is 10. So now I have 2x equals 10. So 2 times x. In order to undo multiplying by 2, I have to divide both sides by 2. So multiplying by 2 and dividing by 2 undo each other. So I'm left with x equals, remember to bring down that equal sign, 10 divided by 2 is 5. And then for example 2, 4x minus 8 equals 24. So I have a 4 being multiplied by the x, and I have an 8 being subtracted. And just keep in mind the left side here is simplified because I can't combine the 4x and the 8 any more than they already are. So because I have an 8 being subtracted, that's what I have to undo first. I have to undo the addition and subtraction first. So add 8 to both sides. I'm adding 8 here to undo subtracting 8, and whatever I do to the left side of the equal sign, I have to do to the right side of the equal sign in order to keep it balanced. So the minus 8 and the plus 8, those undo each other, so they cancel out. I'm going to bring down my 4x, and then 24 plus 8 is 32. And again, remember to bring down your equal sign also. So now you have 4x equals 32. So 4 times x. In order to undo multiplying by 4, I have to divide both sides by 4. Multiplying by 4 and dividing by 4 undo each other. So on the left side of the equal sign, I'm just left with x, which is what I wanted. I wanted to get x by itself. And then 32 divided by 4 is 8. And then for example 3, I have 9x minus 3x plus 12 equals 18. So if we look at the left side of the equal sign and we want to see if this is simplified or not, it's not simplified because we have like terms that we can combine. So like terms are terms that have the same variable to the same exponent. So 9x and negative 3x, those are both like terms. That means that we can simplify this side of the equal sign further. So when we combine like terms, we just either add or subtract what's called their coefficients. Coefficients are the numbers in front. So if I want to combine 9x and negative 3x, I can think of it as if I have 9 x's and then I take 3 of them away, I'm left with 6x. So when I combine 9x and negative 3x, or 9x minus 3x, that's 6x. And then I now need to bring down this plus 12 and then equals 18. And now this equation looks just like these ones now. So I have 6 times x plus 12. So I have to undo the addition and subtraction first. So because I have a plus 12, in order to undo that plus 12, I'm going to subtract 12 from both sides. The plus 12 and the minus 12 undo each other. So I'm going to bring down my 6x equals, remember to bring down the equal sign, 18 minus 12, so 6. And then I have 6 times x, so to undo multiplying by 6, I'm going to divide both sides by 6. So multiplying by 6 and dividing by 6 undo each other, so I'm just left with x equals, and then 6 divided by 6 is 1. And then for example 4, we have 4x minus 3 times parentheses x minus 2 equals 21. So whenever you see a number out in front of the parentheses and different terms or different numbers or variables inside, you have to use something called the distributive property in order to simplify the left side of the equal sign. So one thing that you have to be very careful about with the distributive property is this negative sign belongs with the 3. So it could be a minus or a negative sign, but it has to stay with the 3 when you distribute the 3 to both terms inside the parentheses. So what I'm going to do is I'm going to bring down this 4x and then negative 3 times x. That would become negative 3x. Anytime you multiply a number by a variable, they just get paired together like that. So negative 3x, that means negative 3 times x. And then negative 3 times this 2, but you have to keep in mind that this negative or the subtraction sign belongs with the 2. So this is actually negative 3 times negative 2, which is positive 6, equals 21. And then now we have a problem that looks just like this one. So first, before we use inverse operations, we have to make sure that the left side of the equal sign is simplified. So looks like I have like terms here because I have 2 different terms that have x's attached to them. So 4x and negative 3x. Those are like terms that can be simplified further. So 4x and negative 3x, that's kind of like 4 minus 3. Like I have 4 x's and then I take 3 of them away. So I'm just left with 1x. And you can leave this, you can write this as just x, or you can write it as 1x. It's up to you, we'll simplify it at the end. And then bring down the plus 6 equals 21. And then I have 1 times x or just x. It could be just x like that. Plus 6 equals 21. So I have to undo the addition first. So to undo adding 6, I have to divide both sides by 6. Or sorry, subtract both sides by 6. And then adding 6 and subtracting 6 undo each other so they cancel out. I'm going to bring down 1x, or I can just write it as x. So at some point you should just drop the 1, what's in front of it, and just write it as x. And then 21 minus 6 is 15. And we're actually done here because there's nothing being multiplied by x that we need to divide by. So anytime you have the 1x here, you can just remove it during one of the steps, and then we don't have anything else being multiplied by x, so our final answer is x equals 15. And then for example 5, it's 12 equals 1/2 times x plus 4. So I have this fraction that's out in front of the parentheses with different terms inside the parentheses. So unfortunately, like normally we undo addition and subtraction first, but I can't just like subtract 4 out of here because it's inside the parentheses. So I have to find a way to get rid of them first, and I have to use the distributive property to do so. So I'm going to bring down this 12 equals, and then I have to take my 1/2 and I have to multiply it by both of the terms inside the parentheses, and the terms are just like separated by plus or minus. So 1/2 times x, remember anytime we take a number and multiply by x, it just becomes the coefficient. So we write it as 1/2 x, that means 1/2 times x. And then 1/2 times 4. So if you want, you can write it here, you can write it off to the side. If I do 1/2 times 4, that can look a little tricky sometimes, but anytime you're multiplying a fraction by a whole number, you can, instead of just writing 4, you can write it as 4 over 1, and that might make it easier. So when you're multiplying fractions, you can either multiply straight across and then reduce, or you can cross cancel. And that means multiplying numbers on opposite sides, or sorry, dividing numbers on opposite sides by the same number. So like 2 and 4 are both divisible by 2, so I can divide them both by 2. So 2 would become 1, and then 4 would become 2. So this is 1 times 2, which is 2, over 1 times 1, which is 1, which anything over 1 is just itself. So when we do 1/2 times 4, that's just plus 2. Anytime you need to multiply something by 1/2, you can also just divide it by 2. That works also. So now we have 12 equals 1/2 x plus 2. We can undo the addition first. So we're going to undo the plus 2 by subtracting 2 on both sides. And then 12 minus 2 is 10 equals 1/2 x. And then whenever you have a coefficient of a fraction, or a number, coefficient of a variable that's a fraction, or a number in front of a variable that's a fraction, if you want to get rid of it to solve for that variable, you can multiply by what's called the reciprocal. So if I multiply by the reciprocal, which is 2 over 1, you just have to flip it upside down. Remember, this is an x variable, not a multiplication sign. I need to multiply, if I multiply my right side by 2 over 1, I also have to multiply my left side by 2 over 1. If it helps, you can write this as 10 over 1, but you don't have to. So when I multiply my left side by 2 over 1, 2 times 10 is 20. And then 1 times 1 is 1. So it'd be 20 over 1, but you don't have to write the over 1. And then when I multiply 1/2 by 2 over 1, they cross cancel. So like the 2, if I divide 2 and 2 by, or if I divide 2 by 2, it becomes 1. If I divide this 2 by 2, it also becomes 1. So everything cross cancels and you're just left with x. So anytime you have a coefficient of a variable that's a fraction, you can multiply by that fraction flipped upside down in order to get the variable by itself. So that always works. So our solution, for example 4, would be x equals 20. And then this should actually say example 6. But so we have n minus 4 over 3 equals 10. So most of the time you want to undo the addition instruction first, but we actually can't here because we can't add this 4 because it's already being divided by 3. So in order, if you have something that's set up like this, n minus 4 divided by 3, we first have to get rid of this 3 in the denominator in order to be able to add the 4 over. So if I want to, this is basically n minus 4 divided by 3. So if I want to undo dividing by 3, I need to multiply both sides by 3. So multiplying by 3 and dividing by 3 cancel out. So on the left side, I'm just left with n minus 4. And then 10 times 3 is 30. And then now I just have subtraction that I have to undo to get n by itself. So I can undo that subtracting 4 by adding 4. Then subtracting by 4 and adding 4 undo each other. I can bring down my n equals, and then 30 plus 4 is 34. And then for practice, this would be a good time to pause and try these problems on your own and then check your answers once you're ready. So for 3x minus 7 equals 2, the left side is simplified, and I can undo my subtraction first, so that's what I'm going to do. So I'm going to add 7 to both sides, get 3x equals 2 plus 7 is 9, so I just brought down my 3x here, and then 3 times x equals 9. So I'm going to divide both sides by 3 in order to undo that 3 times x, because I want to undo whatever is being done to x so I can get it by itself. So when I undo the multiplying by 3, I'm left with x on the left side, and then 9 divided by 3 is 3. And then for practice number 2, 8 plus 3x equals 41. I need to undo, or I can undo the addition instruction first. We want to move everything away from the x, so our goal is to get this x by itself. So because this is a positive 8 right here, if I want to undo this, I can just subtract 8 from both sides. It doesn't really matter what this sign is right here. It matters that this is a positive 8, so to undo positive 8, I'm going to subtract 8 from both sides. And then I'll bring down my 3x, and then 41 minus 8 is 33. And then 3 times x equals 33, so to undo multiplying by 3, I'm going to divide both sides by 3. And then I'm left with x equals 33 divided by 3 is 11. For number 3, we have 6 equals 12 times 2 minus x. So this right side of the equal sign is not simplified because I have those parentheses there. So in order to simplify, I need to use the distributive property. So 6 equals, I'm going to take this 12 and distribute it to both of the pieces inside the parentheses. So 12 times 2 is 24, and then 12 times, remember this negative belongs with the x, so it has to be 12 times negative x, and a positive times a negative is a negative, so this would be minus 12x. And then now I have 6 equals 24 minus 12x. I need to undo addition and subtraction next now. So because this is a positive 24, if I want to cancel out this positive 24, I have to subtract 24 from both sides. And then 6 minus 24. Since 6 is positive and the 24 is being subtracted or it's negative, we can think of this as like 6 plus negative 24. And we need to find the difference between the two and then take the sign from the larger absolute value. So the difference between 24 and 6 is 18, but because the 24 is negative and the 6 is positive, our answer will be negative because there's more negatives than positives. The positive 24 and the negative 24 have canceled out, and then equals, I have to bring down my negative 12x. So now I have negative 12 times x, so I'm going to divide both sides by negative 12 to undo multiplying by negative 12. So dividing and multiplying undo each other, so on the right side I'm just left with x, and then 18 divided by negative 12. Well, I know a negative divided by a negative is a positive, so the first step I can do in reducing this could be 18 over 12, but this is a fraction that can be reduced further. So because they're both divisible by the same number, I can reduce it further. The largest number that goes into both of them is 6, so I'm going to divide both by 6, and if I divide the top and bottom by the same number, the fraction will stay equivalent. So when I do that, 18 divided by 6 is 3, over 12 divided by 6 is 2, so x equals 3 halves, or 3 over 2. And then for number 4, 3 times x minus 2 equals 18. The left side here is not simplified, so in order to simplify, I first have to distribute. So 3 times x is 3x. 3 times negative 2, because the negative has to belong to the 2. So 3 times negative 2, a positive times a negative is a negative. So equals negative 6 or minus 6. And then equals 18. So 3x minus 6 equals 18. And then I can undo my subtraction. I can undo subtracting 6 by adding 6. So the subtraction and addition undo each other. I'm going to bring down my 3x equals 18 plus 6. So 18 plus 6 is 24. So I have 3x equals 24. And then I have 3 multiplied by x, so I can divide both sides by 3 in order to undo multiplying by 3. So the left side of the equal sign will just be x, which is what we wanted, is x by itself. And then 24 divided by 3 is 8.